Logarithms, challenging equations with logs. These are some challenging logarithm equations to practice solving. Be careful, they require the log properties. I would suggest that you pause the video right here, try example 1, come back and see how I did it, then go on from there. Assuming you've done that, we have two logarithmic logarithms here. They have the same base. We're adding them together. That means that we can combine those into a single logarithm with the same base and then multiply the two arguments. So that will be negative 35x. And it still equals 3. Now, rewriting this into an exponential, we have 3 to the third is equal to negative 35x. 3 to the third, that is 9, equals negative 35x. Dividing both sides by negative 35, we have a negative 9 over 35 is equal to x. And that is our solution to example 1. Now, really, we should plug it in and make sure that, have a look, that it will solve this. So if we plug in a negative x value here, then this becomes positive, and that's good because you have to have a positive argument for a logarithm. So it looks like it should be a solution. Example 2 here, we have two logarithms with the same bases, 8, but this time we're subtracting them. That means that we're going to have a fraction in the combined logarithm. Log base 8, the x becomes the numerator, and the x plus 2 is the denominator, and that equals 1. So at this point, we can rewrite this into an exponential. 8 to the first power is equal to x over the quantity x plus 2. To get rid of that fraction, we're going to multiply both sides times the denominator, which is the quantity x plus 2. On the left-hand side, this is just 8, so we're going to distribute and get 8x plus 16 is equal to x. Now here, we're going to, I'm going to subtract 8x from both sides. We'll get negative 7x is equal to 16. And finally, dividing both sides by negative 7. We will get x is equal to negative 16 over 7. Now, it's important to, again, check. Whoops, sorry about that. Negative 16 over 7. So it's important to check that that works. When I plug a negative value in here for this right here, the argument of this logarithm is negative, and that doesn't work. In fact, this is smaller than negative 2. So when we plug it in here, we also get a negative argument, which doesn't work. So the actual answer here, be careful, is no solutions. So it's important that you make sure that that's clear in your answer. All right, example 3. Oh, this one's a little different. Notice that there's no base written in. Remember, that means there's a base 10. So we have two logarithms that are base 10, and we're adding them together. That means we multiply. So we have log base 10 of the quantity 5 times the quantity x squared minus 5 is equal to 2. And so this is 10 squared is equal to, and I'm going to distribute 5x squared minus 25, 5x squared minus 25. Now I can add 25 to both sides. And this is 100 plus 25 is equal to 125 is equal to 5x squared. Dividing by 5, 25 is equal to x squared. Square rooting both sides, we get x is equal to positive and negative 5. So checking our answer, if we plug a positive 5 in there, this becomes 0. And we cannot take log, we can't take logarithm of 0. I thought this one had a solution, but it appears that it doesn't. Well, hopefully you just took some time to look at that like I did and realized, wait a second, when I plug a positive 5 in here, this is 25 minus 5, which is 20. That's just fine. When I plug a negative 5 in here, this is again 25 minus 5, which is 20, just fine. So our solution is positive and negative 5. Don't know what was happening there with me for a moment. Sorry about that, folks. All right, example 4. So here we have an exponential, and we're going to need to solve for x. The variable is in the exponent, which means we're going to have to probably convert this to a logarithm. Divide by negative 7 on both sides. We get 19 to the 7x is equal to, well, let's see, negative 92 divided by negative 7. Let's just look at our calculator here. Whoops. Sorry about this. Here's a screen. All right. So negative 92 divided by negative 7 is a negative, well, it's a fraction. So let's just leave it as 92 over 7. And then we can convert that to a logarithm. Log base 19 of 92 over 7 is equal to 7x. And if we divide by 7 on both sides, then the way that we can write that is x is equal to this is a confusing looking fraction, log base 19 of 92 over 7. All of that is over 7. And now we can put that in our calculator to check, or to convert it to a different, to an estimate. So let's see, math, let's go to logarithms. Log base, there we go. Log base 19 of 92 over 7. And I'm going to take that, hit enter, and now I'm just going to divide that answer by 7. And I get an estimate, so x is approximately 0.125. And so that is our estimate for that problem. And that is those are 4 challenging equations with logarithms. Thanks for following along.